Even though this is Unit 5.5, I am putting it right behind Section 5.1 because it's still a Riemann sums. It's just a different rule, the trapezoidal rule. So in this section, we're going to approximate the definite integral using the trapezoid rule. I have here and Simpson's rule. I only do that when we have time, and right now I don't feel we have time. So Simpson's rule is a BC topic, not a AB topic, so that's why we're going to kind of put it off for now. The trapezoid rule, to approximate the integral from a to b of f of x dx, the trapezoid rule is h over 2, your first y value plus 2 times your second y plus 2 times your next one, and on. This is your initial y value, and on and on and on and on, till you get to the very last one. Notice it's only these ones that are multiplied by 2, all of them in the middle, where a and b is partitioned into n subintervals of equal length, where h is equal to b minus a over n. It's your delta x, guys. Okay, h is simply delta x, which is going to be your ending point minus your beginning point divided by the number of intervals. So equivalently, the trapezoid is simply the left Riemann sum plus the right Riemann sums divided by 2. And so that's basically what it is that it takes the average of the two. And no, this is not going to give you the midpoint. It is actually going to be even more accurate than the midpoint rule. So you can see this one here, trapezoids. We're going to start having trapezoids. So you look sideways at this thing. Here's your top base, your other base. Your height is going to be the distance between your two x values, and then your base. And we continue on, and you can see you're going to get a little bit more of an accurate answer, because like here, you got very little that's coming outside. Yes, we got a lot out here, but we got some here. You can also see when you have the concave down, you're going to get more of a underestimation, where if it's concave up, you're going to get more of, so concave down is going to be more of an underestimation, where concave up will be more likely an overestimation. Now, don't be fooled. Down here where it's below the x-axis, guess what's happening? It's concave up, but you're getting an underestimation because it's the equivalent, because it's below the x-axis. So it's kind of, these are flip-flopping. Don't worry too much about it. We're going to go through this, and you'll be able to tell if you're getting an over or underestimation. So the very, very first problem, this is one of those that we did before. It says use the trapezoid rule with n equals 4 to estimate the integral of 1 to 2 x squared dx. Now, this may not mean anything to you right now, but by the end, by section 5.3, you'll know what it is. Compare the estimate with the value of, and this is just their way of saying to put it in the calculator. Okay, that's all they're telling you here, and I'll tell you what buttons to push on the calculator. So they want you to compare the estimate with the actual value that you would get on the calculator. So trapezoid rule. On this one here, so we need h, which is just simply delta x, which is going to be 2 minus 1 over 4, because they told you to do 4 intervals. So it's going to give you 1/4. So the trapezoid 4 is going to give you h over 2 times your first y value plus 2 times your second y value plus the third y value plus the fourth y value. I say 3 and I write 3. 2, 3 plus your last one. Now, keep in mind that this should identify 4, but notice you're going to have 5 items in here. Because from here, this would be the left Riemann sum, and from here to here would be your right Riemann sum. Now, I do know people that they'll do the left, they'll do the right, and then they divide it by 2. Because for them, it's just easier than learning a new rule. They just go through going, okay, I'm going to find the left, I'm going to find the right, I'm going to add them together, and then I'm going to divide by 2, because keep in mind your h is simply your delta x. So you would have taken care of that in the problem. So let's go through this one here. So if I'm starting at, I'm only going 0 to 2, then my intervals would be, and I said 1/4, so 0 to 1/4, and 1/4 plus 1/4 is going to give me 1/2, and 1/2 plus 1/4 will give me 3/4. I'm not doing this right. Oh, because we're going 1 to 2, I'm doing 0 to 2. Oops. Yes, it's okay to make a mistake as long as you realize it before you finish the problem. Sorry, we're starting at 1. 1 to 1 1/4, or 5/4. And then 5/4 to 6/4, so I'm just adding 1/4 to it. And I'm leaving it in the denominator is 4 on purpose. And then the next one is 6/4 to 7/4, and the last interval will be 7/4 to 2. So if we're looking at this, now keep in mind h equals 1/4, and if I divide that baby by 2, it's really 1/4 times 1/2, which gives us 1/8. That way we have our h value. So I need to know on all of these values here. So if I go through and go, well, x, then I'm going to use 1, 5/4, 6/4, 7/4, and 2. And then I want my y value, which is just simply x squared. Then I'm going to get 1, 25/16, 36/16, 49/16, and 4. So I go back to this guy here, so my h value is 1/8, parentheses, 1 plus 2 times all of these values. So 25 plus 36 plus 49 all over 16. See why I left all my denominators the same? Plus 4. Okay, we just continue doing the math at this point. If you wanted to throw it into the calculator, you could. I'm going to get 1 plus 110/8. Yes, I reduced here and then just added these up. Plus 4. I need a common denominator of 8, or I could reduce this, but you know, whatever. I'm debating on how to do this one here. So I think I'm just going to throw it in the calculator, get answer. So this is 1/8, and I throw this into the calculator. I'm going to get 150/60. 150/8. Sorry, I was looking ahead of myself. And multiply it through, you're going to get 150/64, which is approximately, we can go in there, approximately 2.344. Rounded, once I rounded it. Now, calculator-wise, how to do I do this in the calculator? Calculator. You're going to do a alpha window four. And it's going to give you this, and it's going to have a little box down here, a little box up here, a box here, and then it'll say D, and it'll have a little box here. Well, what you would do once you got this is you're filling in the blanks. We're going from 1 to 2. This is considered your lower limit of integration, your upper limit of integration. What you're integrating, which is going to be x squared. And then this is just dx. So you want to know the value of x squared from 1 to 2 dx. And it is going to do the antiderivative for you, is what it's going to do. It's going to do all that work for you. Well, guess what? For this, you're going to get a 2.333. So you should be going, oh, I did get a little bit of overestimation. But if they compare it and ask you for like an error on this, it's going to be your trapezoid minus the integral divided by the integral. So anyways, 2.344 minus 2.333 all over 2.333. And if you throw that into the calculator, and unfortunately I don't have that in the calculator yet, 2.344 minus 2.333 gives us 0.011. Divide that by 2.333, and you get 0.00471. If we move our decimal over, then it's going to be a 0.471%. So that's how much of an overestimation it is by basically 47 hundredths, which is not a whole lot. And so it's a very good estimation. We have a really good estimation here. Now, can we get better? Of course, we do larger intervals. That's how you get a better value. Your error is going to get smaller as your answer becomes more accurate. Go figure, right? Okay, so let's try another one. So on this one here, we're going to do 0 to 2 of x cubed, and actually use the trapezoid rule with n equals 4 to approximate the value of the integral. Use the concavity of the function to predict whether the approximation is going to be over or under, and then find the interval exact value to check your answer. So there's a couple of ways that you can use this idea. So we're going to do each piece by itself, and we are going to do the percent error as well. So 0 to 2, by the way, we can go ahead and throw this in the calculator, but then I want the answer to part B before you do part C. So, but we can also do part B before we do part A. So let's go ahead and do that. Let's do part B first. So we got part A. We're going to just kind of set it aside and do part B because our function is x cubed. So if I do the first derivative, I get 3x squared. If I do the second derivative, I get 6x. And my point of inflection would be x equals 0, which tells me that from negative, but you know what? We only want from 1 to 2, or 0 to 2. So this really isn't going to make that big of a difference. From 0 to 2, I'm concave up. Now, if you're going, wait, why? Because this will always be positive from 0 to 2. And I'll put a positive number in, I get a positive number back. It's always going to be concave up. And concave up tends to give us an overestimation. So we already looking at this going, oh, we're going to have an overestimation. So let's go ahead and do part, yes, I'm going kind of backwards. Let's do part C. If I threw this into the calculator, and remember, you do alpha window 4, and the program will come up for you to plug things in. So let me do that, alpha window 4, and if I go 0 to 2, of x cubed, I'm going to get 4. So now that we're predicting that it's an overestimation, guess what? With that idea, we're going to expect to get an answer larger than 4. All right, so let's go in there and see what we get. So part A. I know, hopefully I didn't throw you guys off with doing the others, but you should never do part C on this one, A and C, and then go back and do B. Either do them in order, A, B, C, but I figured going, you know what, all I have to do is use my old information, going, okay, it's concave up, so at concave up, it's going to be probably an overestimation. I can go ahead and calculate what my calculator is going to give me, and then I just have to finish up the trapezoid roll. So on this one, H is equal to delta X, which is B minus A over N. So in this case, 2 minus 0 over 4, because they told us to do it in 4 intervals. which is going to give me 1/2. So we're starting at 0, and we're just using 4, so it's going to be 0 to 1/2, and then 1/2 to 1, and then 1 to 1.5, so 3/2, and then the last one, 3/2 to 2. Okay, so we're ready to go. My x, so this is my my values. So my x values I'm going to be using are 0, 1/2, 1, 3/2, and 2. And yes, you should have one more than your end value. Your end value is 4, 1, 2, 3, 4, 5. And I want to know what that value is when I cube it. So I get 0, 1/8, 1, 27/8, and 8. So my trapezoid of 4 is going to be, oh, we didn't figure out the h over n. H over n is going to be 1/2 over 2, or 1/4. So this is 1/4 times 0 plus 2 times, bear with me on this one, 1 plus 8 plus 27 all over 8 plus 8. Guys, I took this guy and 1, and to get a common denominator, I just had to do 8/8. So that way I can put all these guys together. I am going to go ahead and clean this up and make this 4. So I have 1/4. I don't need the 0 anymore. And I'm going to get here, 9 plus 27 is going to give me 36/4 plus 8. So this is 1/4 times 9 plus 8, which gives me 17/4. And if you must round it to a decimal value, it's 4.25. And you guys are going, no surprise, we got a number larger than 4. We expected it because we did part C first. Actually, part B. We did part B first. We knew we were going to get an overestimate. We did part C, got 4 as the actual value, and we're getting 4.25. So error-wise, 4.25, remember subtract, 4. Yeah, I had it right. 4.25, the trapezoid, sorry, let me write it. Trapezoid minus the integral divided by the integral. Minus 4 all over 4. So we're going to get 0.25 divided by 4, which is 1/16. But if I wanted the value of 1/16 as a decimal, 1 divided by 16 gives me 0.0625 times 100, because we want percent. This is actually, you know, we look at it going, well, this isn't too bad. But we get 0.0625, that's the error, but in percentage-wise, we're 6.25%. That's a very large error. You don't want to have that big of an error. So, and it's because we're looking at a much larger part of the graph, and so we're getting just a little bit too much of the information. Okay, I do realize we are at 19 minutes, but we'll probably take about 5 minutes to finish this last one up. Maybe 10. Because they're asking you to do the same thing again. So let's go ahead and throw this guy into the calculator. So I'm going to do C, B, and then A. Let's throw this guy into the calculator. If you put this all into the calculator, you're going to get 0.693. Anyways, you're not getting any kind of a nice number at all. Now, what we have to realize is that 1/x from 1 to 2, and you can put this in the calculator as well to look at, is that this is getting closer and closer to 0. So what's happening is your graph is doing this. Your graph is concave up again, but it's also decreasing. So the question on this one is whether or not it's going to be over or under estimation. Now, one of the things that we can do on this one, again, like I said, it's concave up, is we can do derivatives on this thing. First derivative is going to give us a negative 1 over x squared, and the second derivative is going to give us a positive 2 over x cubed. This will always be positive. Concave up, but we already knew it was concave up. And so we're looking at this going, now am I going to get an overestimation or an underestimation? Most likely still we're going to get that overestimation because it's concave up. And it tends to give us an overestimation on the concave up. So we're still going with this guy here. So, and we already got part B with the exact value. So let's do the trapezoid rule. So H is going to be, let's see, we're going from 1 to 2 again. 2 minus 1 divided by 4, which is going to give us 1/4. And H over 2 is the same as 1/4 times 1/2, which is going to give us 1/8, just like the first problem we did. And our intervals are going to be the same as that first problem because we're doing 1 to 2. So we're going to go 1 to 5/4, 5/4 to 6/4, 6/4 to 7/4, and then 7/4 to 8. Okay, 8 over 4, 2. So my x values I'm going to be testing is 1, 5 over 4, 6 over 4, 7 over 4, and 2. And I want 1 over x. So guess what we're going to do on all of these babies? We're flipping them over. 1, 4 over 5, 4 over 6, 4 over 7, and 1/2. So our trapezoid of 4 is going to be 1 over 8 times 1 plus 2 times 4 over 5 plus 4 over 6 plus 4 over 7 plus 1/2. And I'll be honest with you, at this point, I pretty much just threw this baby into a calculator and got an answer of 1171 over 1680. And there's nothing wrong, just make sure you put it in the calculator right, which is approximately 0.697. Now, when we did the calculated part, we got 0.693. So remember, it's to check, to compare, is the trap minus the integral over the integral. So 0.697 minus 0.693 divided by 0.693. So we throw that into the calculator. 0.693. That's going to give you 0.004 over 0.693 divided by 0.693 gives us 0.005772. And when I move this decimal over to get a percent, that gives me 0.577%. So that's how much we overestimated by 0.5%. So not bad. Compared to the last problem where it was 6%. That's how much we overestimated. So we overestimated by about 0.6%. So, which is not bad at all. Closer to 0, the better. Okay, so that is it. The rest of our notes was going to Simpson's rule, and we're not doing Simpson's rule. So, and 24 minutes is a long enough video. So good luck on the homework. Now you're ready to do all of 5.1 homework. And good luck on it.